Module, we're going to introduce you to the Java programming language. We're going to learn about the Java virtual machine, and we're going to write, compile, and execute a Java program. So let's get started. In this module, we'll be describing the key features of Java technology. We'll write, compile, and run a simple Java technology application, as well as learn about the Java virtual machine and describe its function. In addition, we'll be defining what garbage collection is and listing the 3 tasks performed by the Java platform to handle code security. Java technology is many things. For one, it's a programming language, and its syntax is very similar to C++. Also, it is a development environment. It provides you with a large suite of tools, such as a compiler, an interpreter, a documentation generator, a class file packaging tool, and many other things. It is also an application environment. Java supports not only standalone applications, but applets, web server applications, such as JSP pages and servlets, as well as enterprise applications, such as Enterprise Java Beans. Also, Java is a deployment environment. Java can be deployed on an operating system, inside of a web browser, on a web server, or in an application server. The developers of Java technology had many goals for it in mind. For instance, they wanted it to be multi-threaded so that it could carry on more than one task at a time. They also knew security had to be built into it from the beginning. They also wanted it to be able to load its class files dynamically so that programs could be changed easily and be more flexible. They also knew it had to be an easy-to-use language, much easier than the C++ language, which was very popular at the time. And they wanted the language to avoid many of the programming pitfalls of other languages, such as memory leaks. They also wanted it to be completely object-oriented from the beginning. And Java applications needed to be portable so that they could be run on many platforms. The Java virtual machine is a virtual computer that is implemented either in software or hardware. It has its own instruction set, register set, stack, its own memory area, its own garbage collected heap. It basically reads a compiled bytecode format that is platform independent and interprets that, executing commands on the operating system that it's running on. The Java virtual machine can be implemented in many places. It can be implemented in a development tool, in a web browser, as a standalone application, inside of a database, even inside your cell phone. One of the best features that Java has over other languages like C++ is its ability to track memory and determine when an object is no longer needed and to automatically deallocate the memory that it's using to free that memory. This eliminates the problem of memory leaks that other languages have and greatly reduces the amount of programming effort that software developers have to do. Let's go ahead and take a high-level view of how our Java source code files get compiled and then executed by the Java virtual machine. So on our left-hand side, we can see we have a file called testgreeting.java. This is our source code file. All Java source code must be in a .java file. We then use the javac command, which is the Java compiler tool, to compile our source code. If our compilation is successful, we will get out a bytecode file, which is a .class file. So in this case, we would get testgreeting.class. Now the bytecode file is not an executable file. It's that intermediate bytecode that will be interpreted by the Java virtual machine at runtime. Then we execute the Java virtual machine by issuing the Java command. The Java command will load the Java virtual machine, and the Java virtual machine will then load our testgreeting.class file. So once again, you cannot execute the .class files. You instead execute the Java virtual machine, which will load our class files and then interpret them on our behalf. So as you can see, our Java virtual machine on the right-hand side has many pieces to it. One of those pieces is the class loader. The class loader is responsible for loading our .class files. It can load class files from the local hard drive, from a network resource, and even over the internet. If you click on the class loader link, you'll see some more information about it. Now, the class loader loads all the class files that are necessary to execute the program, and it does this dynamically. That means as the class files are needed, so it doesn't have to load them all at once. If a class file isn't necessary during a certain execution of the program, it won't load it. It will also make sure that all of the local file system classes are kept in a separate namespace than network or internet class files. This is to help prevent spoofing. What the class loader does is it makes sure that if there are two class files with the same namespace and name, that the local file system one will always execute instead of the network one, since it is assumed that the local file system one is safer than the networked one, since it has been stored locally on the hard drive. After the class files have been loaded by the class loader, they are then run through the bytecode verifier. Go ahead and click that link. The bytecode verifier will make sure that the .class files that have been loaded adhere to the JVM specification. That means that there isn't anything in there that might be a security risk. It makes sure that there's no code to cause a stack overflow or an underflow, that all the parameter types are correct, that there are no illegal data conversions to try to manipulate memory through the conversion of integers to pointers, for instance. So it makes sure that no one's put something in there that could potentially be unsafe. Then, after the bytecode has been verified by the bytecode verifier, it moves to the interpreter. It is the interpreter's job to go ahead and interpret that bytecode into the appropriate operating system commands and pass that over to the runtime environment, which then executes that on the hardware. So that is the basic steps of how our Java source code gets compiled and then executed on a specific platform. Now go ahead and click the JRE with JIT compiler. So now that we understand a little, let's go ahead and take a high-level view of how our Java source code files get compiled and then executed by the Java virtual machine. So on our left-hand side, we can see we have a file called testgreeting.java. This is our source code file. All Java source code tab. Now the JIT compiler stands for just-in-time code generation. And basically the same steps happen to take our source code to execution. However, with a JIT compiler in the JVM, so instead of the bytecode being interpreted over and over again, the JIT code generator will take it and compile it into the native operating system commands ahead of time and then execute those commands directly. This makes the Java code execute much faster and gets it closer to a language such as C or C++. That's because the bytecode doesn't have to be interpreted over and over and over again. So now that we understand a little bit about how a source code file gets compiled and then executed on a platform through the JVM, let's take a look at an example Java program. Here we have two Java source code files, testgreeting and greeting. Now the testgreeting source code file would be in a file called testgreeting.java. The class name must always match up with the file name. So if the class name is testgreeting, the file must be testgreeting with a .java extension. So therefore, the greeting class on the right-hand side would have to be in a file called greeting.java. And you must make sure that the cases match appropriately. So it is case sensitive between the class name and the file name. So let's first take a look at our testgreeting file. The testgreeting class has one method in it, the main method. The main method is the entry point into your program. It's the starting point of your program. All Java applications have a starting point, and a standalone Java application starting point is the main method. So your program must have a main method in some class. It doesn't matter which class you put it in, but most of the time we have a class that's just set aside to act as the housing for the main method. Then in this main method, we are going to create a greeting object using the new operator, new greeting. And then on that greeting object, we are going to call the greeting object's greet method. So hello.greet. That will invoke the greet method on that object. If we look over at the greeting source code file on the right-hand side, we see the class greeting and then we see its one method called greet, which will print out one word onto the command prompt window, and that word is hi. So basically, this is a sample Hello World application. It's just going to run and print out the word hi onto the command prompt. So once we've gone ahead and created the greeting.java and the testgreeting.java files, it's time for us to compile them. To compile these files, we will issue the Java C command. The Java C command is the Java compiler. So in the command prompt, in the directory where you have stored these files, you would type Java C and then give it the name of the file that you want compiled. In this case, we could type Java C testgreeting.java. Now, this will also compile the greeting.java file, since the testgreeting file relies upon the greeting.java file. So basically, the compiler goes out, sees that greeting.java hasn't been compiled yet, and is needed to be compiled for it to compile testgreeting, and so it will also compile that file. This is a dependency between these two files. Testgreeting depends upon greeting.java, and the compiler is smart enough to figure out when it needs to recompile these dependent files. Once we've compiled these files successfully, we can run the application. To do that, we need to use the Java command. The Java command will launch the Java virtual machine and then will run our class files for us. So we type Java and then we give it the name of the class that has the main method in it. So it would be Java testGreeting, since the testGreeting class has the main method. You would not say greeting because that class does not have a main method. Also, you would not put on a .class extension or a .java extension. You just give it the name of the class. Click the Possible Types of Errors tab. Here we've listed some of the possible errors that you might encounter while trying to compile your program or running your program. First, Java C not found. If you get this error message, then you have not correctly set your path to where the Java C utility is located, and you will need to do that. Click Cannot Resolve Symbol. If you get a message like this, that it cannot resolve a symbol, then you may have mistyped something in your source code file. As you can see in this error message, we've mistyped println for print line. We have printl. So we will have to go back in our source code file and fix that. Click the class name / file name do not match error. I mentioned before that your file name must match your class name and then has a .java extension. So if your class name is testgreeting, you must have that source code in a file called testgreeting.java. Here we can see that we've accidentally saved our testgreeting class in a testgreet.java file. This is incorrect, so you would get an error message something like this. Now click on the cannot find class message. If you get an error message like this, then it's possible that you are not in the correct directory when you are typing the Java command. So make sure that you are in the same directory as your .class files when you are executing. Or maybe you've forgotten to compile. So you can't run the program until you actually have compiled it. So make sure that you've done that as well. Or you may have a problem with the way your class path has been set up. And we'll be talking about the class path in a later module. Click the cannot find main method error. Now this would happen if you are trying to execute a class file that does not have a main method. So if we said Java greeting and we tried to run the greeting class file, the greeting class file does not have a main method, and we would get an error message like this. So let's go over the steps one more time to see all that is happening during the compilation and the running of our Java program. Once again, in our example, we have two source code files, testgreeting.java and greeting.java. We compiled testgreeting.java using the Java C command. The Java compiler then also compiled the greeting.java file for us. So when this compilation step was done, we were left with a testgreeting.class file and a greeting.class file. We would then run the program using the Java command and giving it the testgreeting class name. The Java virtual machine then loads testgreeting.class. It will also sense that it needs the greeting.class file and will load that as well. It will then begin to interpret the bytecode from those class files and issue the appropriate operating system commands. In this module, we discussed the key features of Java technology. We wrote, compiled, and ran a simple Java application, as well as discussed the Java virtual machine and described its function. Also, we defined what garbage collection was and how it worked, and listed the 3 tasks performed by the Java platform to handle code security.